All right, let's start. So in today's lesson, we are going to continue four more strategies. Okay, yesterday we learned 4 strategies. So today we are going to learn 4 more strategies. Strategy number 5 is called constant difference. Strategy number 6, the remainder concept or the branching method. Okay, branching method is very, very powerful method. Strategy 7, number times value. Strategy 8 is called the supposition or the assumption strategy. Okay, now can you tell me who knows all these 4 strategy? Who is familiar or you know very well these 4 strategy? Okay, you have learned all, but something you get confused on the assumption method. Nope. Okay, who know none of them? Who do not know any of this strategy? You got no clue what is talking about. Okay, no worries. Especially the P5 student. Anybody P5 here? Okay, some of the P5 student, you may find it. In fact, many of these strategies are taught in Primary 3 and Primary 4. Okay, but the simpler ones. But no problem. Sometimes, if you're lucky, your teacher in school may have taught you and you remember them. Okay, but sometimes your teacher may not have the time or may not teach you some of these shortcuts and strategies. Okay, so that's why you are here, all right, so that I can share with you so that you are better equipped to solve the more challenging maths questions. Okay, all right, now let's take a look at the next, the first strategy. Let's take a look at the first strategy. The constant difference strategy. Okay, the constant difference strategy. All right. Okay, let me test with the marker or too thick. Okay, constant difference strategy. All right. Now, when do we use constant difference strategy? Okay, those of you in my maths class, you may have done recently questions involving age. Okay, so some of the keywords, key terms that you need to use this strategy is unchanged difference, constant difference, clues such as both receive an equal amount, both give an equal amount, or any questions involving age. Okay, you can use 2 main methods. One is using the model method, the other one to use the unitary method. Okay, so I'm going to share with you first using the model method, and then we're going to learn a shortcut method using the unitary method. All right, so you are equipped with more methods and more strategies, and you're able to better solve the different kinds of questions in the exam. All right. Okay, so 3 different situation. Number 1, word problems involving difference in age. Okay, involving difference in age. When you see any question involving age, okay, one of the method is likely that you can use is this method, constant difference method. Okay, so when 2 individuals receive an equal amount from a third party, or when 2 individuals give an equal amount to a third party. Okay, now let's take a look at an example. Okay, now let's read this together. When Mrs. Tan is 29 years old, her daughter is 5 years old. In how many years' time will she be 4 times as old as her daughter? Okay, now anybody can solve this question. Anyone can solve this. Okay, I give you all 2 minutes to solve this. You all have your paper, right? Okay, try and solve this. Any method you have learned. Okay, now try and solve this question. I give you 2 minutes. You can draw model, no problem. Any method. Later on, then I'll teach you several methods. You can use any method. Can you get the answer? 67. Oh, not 67. Yushen. 3. Fuchun confused liao. Ana 6. Adila 8. Okay, don't know? Okay, never mind. Okay, this is what I'm going to continue. Later I'm going to share with you, but before we attempt the question, we need to analyze the question first. Okay, you can see that Mrs. Tan is 24 years older than her daughter. How do we know that? 29 minus 5. Okay, and you notice that the difference between the age will always be the same. Okay, why? Because for every 1 year that Mrs. Tan lives, her daughter will also live additional 1 year. Okay, so that means in 5 years' time, Mrs. Tan will be 5 years older and her daughter will also be 5 years older. Okay, so let's say in 5 years' time, 5 years' time, Mrs. Tan will be 34, right? And the daughter will be 10. So what's the difference in the age? 20, 24. Okay, so you can see in the beginning, okay, it is also 24, and in 5 years' time, the difference in the age is also 24. So you can see that the difference is the same, right? The difference is constant. That's why we call this strategy constant difference strategy. Okay, now another example in which we can use this strategy is when two individuals receive an equal amount from a third party, from someone, receive an equal amount. This is a keyword here, receive an equal amount. Example here, let's read together. Okay, Ali had twice as many marbles as Benny at first. Then each of them bought an equal amount of marbles. In the end, Benny had 36 marbles and Ali had twice as many marbles as Benny. Find the number of marbles Ali have at first. Okay, so you can see that Ali has more marbles than Benny, three times. So each of them bought an equal amount. So it means that if Ali bought one marble, Benny also buy one marble, and so on. So the same amount of increase for each individual. Okay, so with this, you can see in the end, the difference between them is always the same, right? The difference in the beginning and at the end will always be the same. Why? Because each of them bought an equal number of marbles. All right. Okay, let's take a look at, let's try how to attempt the question. Let's go back to the question which you all attempted just now. Okay, so I'm going to share with you first using model method. Using model method. Now let's take a look. Okay, so Mrs. Tan is 29 years old. Her daughter is 5 years old. So for every 1 year Mrs. Tan lives, her daughter lives 1 year as well. Okay, so the difference in age at first will be the same as the difference in age in the end. Okay, now let's draw the model. So we know that the difference is the same, 24, right? Okay, so in the end, Mrs. Tan is 4 times as old as her daughter. So if you were to draw the model, so you can see here, Mrs. Tan 4 units and the daughter 1 unit, right? And since it is constant difference, can you tell me how much is from here to here? Anyone? Will always be 24, correct or not? Will always be 24. Okay, so 3 units is 24, right? 1, 2, 1 unit, 2 unit, 3 units. And 3 units is 24. And 1 unit is 8, right? And then they ask you, in how many years' time? Okay, so at the moment, Mrs. Tan is 29 years old. Okay, at the end, Mrs. Tan, you have 4 units of Mrs. Tan, right? So 8 multiplied by 4, you get 32. Okay, 8 multiplied by 4, you get 32, right? So in how many years' time? So that means when Mrs. Tan is 4 times as old as the daughter, she will be 32 years old. Okay, so in the beginning, she was 29 years old. So 32 minus 29 is 3, right? So the answer will be 3 times in 3 years' time. Okay. Now, Haziq asks, why 32 minus 29? Because 32 is in the end, right? Remember, in the end, Mrs. Tan is 4 times as old as the daughter. So 1, 2, 3, 4. 29 you get from in the beginning. In the beginning is Mrs. Tan is 29 years old. So that's why 32 years old minus 29, which is in 3 years' time. Okay, that means right now Mrs. Tan is 29 years old. In 3 years' time, she will be 32. Okay, and her daughter, okay, will be 1 year, will be 8 years old. Okay, and the difference will always be the same. Okay, Got it, everyone? Devin? Okay, which part you don't understand? Those of you who don't understand, Fuchun, which part you don't understand? Devin? Okay, can you tell me which part you don't understand? The model. Okay, let's take a look at the model. Now, you see, they tell you that in how many years' time will she be 4 times as old as her daughter? So what I'm drawing here is the model in the end, right? The model at the end, which is 4 times more than the daughter. So the daughter 4 times means the daughter 1 unit, Mrs. Tan is 4 units. Correct or not? Okay, Vera asks, how you get 32? Very simple, here, from here. You know, so 3 units is 24, right? Because we know that the difference will always be the same. So which is 24. How we get 24? 29 minus 5, 24, right? And so 3 units, you can see here the difference. This is the difference in the end. And since we know the difference is the same in the beginning or the end, so 3 units is 24. Okay? Correct, right? So 3 units 24. So 1 unit is 8. Then we find 4 units. Why? Because we want to find how old is Mrs. Tan at the end. Okay? Got that? Everybody? David still not sure. Why 32 minus 29? 29. Anybody wants to explain to him? David still don't understand why 32 minus 29. 32 is how old she is in the end. Okay? At the end. 29 is how old Mrs. Tan right now in the beginning. Okay? So they ask you in how many years' time? So 32 years old minus 29, you get 3 years. In 3 years' time. David? Oh, okay. Very good. Now you understand, huh? Okay, so I'm going to show you a second method, which is the units method or unitary method. Are you ready? Can, huh? Okay, let's take a look at the units method, huh? Okay. Now, units method, you don't have to draw model, right? So at first, Mrs. Tan is 29 years old and the daughter is 5 years old, right? So we just put 29 and 5 here. The difference is 24, right? 29 minus 5, you get 24. In the end, Mrs. Tan, okay, I'm just extracting information from the question. So Mrs. Tan is 4 units and the daughter is 1 unit. So the difference between 4 and 1 is 3 units. Okay, so what we do is that we find the lowest common multiple of the difference. Why? Because we know that this is a constant different question, right? The difference in the beginning and at the end is the same. Okay, so what's the lowest common multiple of 24 and 3? Which is 24, right? So 3 units times 8, I get 24. If I times 8 to here, everything also I must times 8, right? Because this comes in one set. So times 8, times 8, times 8, right? So 4 units multiplied by 8, I get 32. 1 unit times 8, I get 8 units. 3 units times 8, I get 24. Okay, so once the difference is the same, then I can compare. So at first, Mrs. Tan is 29. Then in the end, she's 32, right? So you can see the difference is 3. Okay, so you can see the difference is 3, right? Okay, so how do you find? Okay, some of you ask why times 8? Okay, anybody can answer why times 8? Because we need to make the difference the same. Correct or not? Why? Because we know that because this is a constant different questions, the difference in the beginning and at the end is the same, and we need to find the lowest common multiple of 24 and 3. What's the lowest common multiple of 24 and 3? It is 24, right? So how to get 24? 32, 3 units times 8, I get 24. So if I multiply by 8 to here, everything also I must times 8. Okay, Vera? Vera, are you okay? Okay, very good. Okay, I think most of you understand, right? Only a few of you don't understand. Okay, if you don't understand, no worries. When I upload, later you can rewind, you can play again and again, again and again. Okay? So you need to focus. If you don't focus, then you cannot understand. You need to focus on the slides and not on the chat. Okay, you need to focus. Can, Fuchun? Okay, let's take a look at next method. Are we ready? Next method. Okay, next method is what we call the branching method. Okay, the branching. Who have not heard of the branching method? Never try before. Never do before. You not tried? Don't know? Fortune? Okay, I think those of you in my class, I've taught you before, right? Is that, I think you have forgotten. A lot of you have forgotten, huh? Yes, by right, your teacher would have taught you branching method last year when you all learn how to multiply fraction of a fraction. Okay, how to multiply fraction times fraction, then you have learned, but no problem, you have not learned, so that's why you are here. Okay, I'm going to share with you this branching method. I like branching method very much because you can see very, very clearly the steps. Okay, let's take a look at how to solve this question. Okay, so this branching method you can use to solve fractions, ratio, or percentage. Okay, usually you use fraction, involve fraction, and sometimes it can be in percentage. So P5, you have not learned percentage, but the P6s later on, when P6s, if you use, if the topic is on percentage, you can use this branching method. But the only thing is that you need to convert from percentage to fractions. Okay. Now, the keyword to use this is that when you see the word of the remainder, of means multiply. Okay, of means multiply, right? Of the remainder. So you see any terms, any words, part of the question of the remainder, okay, it's likely that you can use this branching method. So I'm going to show you two ways. One is the traditional model method, and then I'm going to show you the branching method, and then it's up to you what method that you want to use. Okay, if you are more comfortable with model method, go ahead and use the model method. If you're more comfortable with the branching method, you find the branching method faster and clearer, go ahead to use the branching method. So you must be open, you must equip yourself with the different strategies. Okay? All right. Now let's take a look at this question. Let's read together. Mr. Tan used 1/4 of his salary and gave 1/3 of the remainder to his mother. Take note here, 1/3 of the remainder. And he gave the rest of his money to his wife. What fraction of his total salary did he give to his wife? Okay. Now let's take a look at the model method. Okay. Now, this model method works in this question because this is a very straightforward question. Okay, so what you need to do is that you need to draw 4 boxes, which represents 4 units. And then 1 unit, he used, right? Mr. Tan used, right? 1 unit, 1/4, you can see here. 1 out of 4 he used. And then this is the remainder. After he used 1 out of 4, he get the remainder. Out of this remainder, he gave 1/3 of the remainder, not of the total. Please take note, 1/3 of the remainder to his mother. So out of this remainder, you can remainder got 3 units, right? He gave 1 out of 3 to his mother. And the rest he gave to his wife. Okay, so the wife gets 2 units out of 4. Okay, and so they ask you what fraction of his total salary did he give to his wife? He gave half of his salary to his wife. So you can see that this is easy peasy lemon squeezy. Okay. Now this is for very simple, straightforward question. Okay, you can easily draw model. Then what about if you have this? Half of a class were boys, 2/3 of the boys, and 1/4 of the girls in the class were Chinese. What fraction of the total number of students were Chinese? Okay, so can you all use model method to solve this? I want all of you to try using model method to solve this question. Okay, I give you 3 minutes to do this. Okay, everybody must try. Fortune also you must try. Okay, I give you all 2 minutes to try. Try your best. You don't know, it's okay. I will discuss later on. Eleven over 12, no. 3 over 7, no. 7 over 12, no. 11 over 12, no. 3 over 7, no. Seventeen over 24, no. Eleven over 24, yes. Hey, who put 24 over 9? Cannot be, Yes, Ishak, very good. I will expect you to get the answer because you got 90 something, right, last year? Okay, so for you, it should be very easy for you, but I think not for the rest. 96, Ishak. Oh, well done. Okay, Ishak got 96 for maths last year. So Ishak, for you, these strategies will be very easy, Okay, I cannot give you all this type of question. I must give you all the platinum kind of question. Okay, is everybody ready? The answer is 11 over 24. Okay, the answer is 11 over 24. All right, let's see how to solve this using model. Okay, it's not so straightforward. Okay, you can see half of a class were boys. Okay, half of the class were boys. 2/3 of the boys and 1/4 of the girls in the class were Chinese. Okay, so if half boys and the other half must be girls, right? So 2/3 of the boys were Chinese. So that means out of these boys, we need to cut into 3. Okay, you get 2 here. And then for the girls, 1/4. So 1 out of 4. So you can see here is we cannot compare the moment. Correct not? Can we compare right now? We cannot compare, right? Why we cannot compare? Because you can see here the units are of different size. Okay? The units are of different size, right? So you cannot compare. So it can become very complicated, right? If you draw the model, so what you need to do, you need to cut into smaller pieces. Correct not? You need to cut into smaller pieces. Okay? How? You need to make into 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, then after that, you count. For boys, how many? 1, 2, 3, 4, 5, 6, 7, 8. And girls, 1, 2, 3, 8 plus 3, you get 11 out of 24. So you can see this is slightly challenging, right? It's really quite difficult, right, for you to draw and for you to draw into smaller pieces. Imagine if the boxes you need to cut into, let's say the lowest, let's say you need to compare between the lowest count multiple of say 9 and 2, for example. So 9 and 7, for example, right? It's going to you need to divide into many smaller pieces. So it's going to be very complicated. Okay, so that's why I'm going to share with you this branching method. Okay, so I want you to listen very carefully, okay, so that you equip yourself with different methods, and then you should be able to better solve the different kinds of questions. Okay, the more technique that you use, the more methods that you have, the better you are, the faster you can solve different types of questions. Okay, now let's come back to this question. Just now, okay, so we know that this question using model is very easy. Now, how do you convert to branching method? Okay, let's take a look at this. Okay, so Mr. Tan used 1/4 of his salary. So this represents his total salary. So he used 1/4, right? Use 1/4. And he gave 1/3 of the remainder. So this is very tricky. Okay, many students, they take 1/3 from here. But no, you need first to find the remainder. Okay, can you tell me how you get 3/4? How you get 3/4? 1/2 minus 1/4, right? 1/2 minus 1/4. So if this is 1/4, okay, salary is 1/2. 1/2 minus 1/4, you get 3/4, right? So you need to find the remainder first, right? Because here they tell you, the question says 1/3 of the remainder. Okay, so the remainder is 3/4. You cannot find one, you cannot say 1/3 of 1/4, no. Or 1/3 of the total, no. 1/3 of the remainder, so the remainder is 3/4. So 1/3 of the remainder means 1/3 times 3/4 and you get 1/4. Okay? And then the wife, the balance you give to the wife, right? Now, can you tell me how you get 2/3 here? How do you get 2/3? 1 whole minus 1/3. Correct not? 1 whole minus 1/3 and you get 2/3. Okay? So the wife is 2/3 of 3/4. Right? 2/3 times 3/4, you get half. And this is the answer. Okay? Okay, so we are going to look at the other question, how to use branching for this question. Remember, this one a bit challenging, right? When you use models, right? Because you need to cut into smaller pieces, into 12 smaller pieces, right? You need to divide them to make sure that the units are of the same size. Now, let's see how you can solve this using the branching method. Okay? So, the number of students, this is 1 whole, right? So, half of the boys, so the remainder will be half are girls, right? Half of the students are boys, the other half must be girls. So 2/3 of the boys were Chinese, so 2/3. So you draw a branch up and you put 2/3 here. And for the girls, 1/4, right? 1/4 of the girls were Chinese. So you put a branch up here, 1/4. So if you get 2/3 here, this must be 1/3. If this is 1/4, this must be 3/4, right? Now what do you do next? Next, you multiply, correct? To find the final fraction. Okay, next you multiply to find the final fraction. Oops. Something hang here. Okay. Okay, so multiply 2/3 multiplied by half, you get 1/3. Okay, and then Chinese 1/4 of the girls, 1/4 of half, you get 1/8. Okay, so the question asks what fraction of the total number of students were Chinese? So you just add them up. 1/3 plus 1/8 and you get 11/24. Right? So you can see very easy. Okay? Hard to do but easy for teacher to mark. No, it's not for teacher to mark. Right? It's for you to understand and for you to see the problem clearly. Right? Remember when you do maths, there are such thing as method marks. Right? If your final answer, let's say it's a 4-mark question. If your final answer is wrong, so what teacher will do is that teacher will see your method. And teacher will want to try to give you marks. Teacher do not like to penalize you, So the examiner wants to give you mark. So you must give a reason or you must show your working clearly so that to give reason for examiner to give you marks. If your handwriting very untidy or your models you never draw properly or everything is in your brain, you say you do everything mental sum, suddenly you get the final answer. No, it doesn't work that way. If your final answer is correct, okay, maybe no problem. They'll give you the marks. But if your final answer is wrong, then that's where you got a problem there. That's why your steps you must draw very, very clear. Unless it is MCQ. Multiple choice, then you don't need to show any steps, right? Because it doesn't carry marks. Okay, but still MCQ, I encourage you to do steps in your answer booklet, in your question booklet itself, so that you can see where you go wrong and so on. Okay? Okay? All right. Yes. Let's take a look at the next one. Okay, before that, advantage branching method allows you to see the different parts of the total at a glance, right? You can see everything very clearly that you can see, and then it is useful for question involving remainder concept. Okay, now this one can also be used for percentage. So if you see percentage question, percentage of percentage, what you need to do is you need to convert the percentage to fraction. I hope you know how to do. Those of you in the P6 class, you should know how to convert by now, how to convert percentage into fraction. For example, 50%, do you know what is 50% in fraction? It's half, right? Because it's 50 over 100. Okay, very good. Okay, let's move on to the next strategy, okay, which is number times value. Are you all ready? Have you heard of the strategy number times value? Never hear before? Okay, have you heard of the strategy called grouping method? Grouping method or set method? This is very similar. Okay, it's very similar. So how to do this question? How to apply this strategy? So when do you use this strategy? When to solve word problem involving proportion. Okay, so some of the clues that you may see is thrice as many as, ratio, fractions, percentage, less than. So the strategy, you can use guess and check or the number times value method. Okay, so guess and check is the traditional method, but I'm going to teach you a shortcut method called number times value. Okay, now let's take a look at this problem. Okay, this is easy problem. I think this is primary 3 question. Now I want all of you to solve this. Okay, I give you 2 minutes to solve. You can use your paper, whatever method they use. It doesn't matter. Whatever method that you want to use, no problem. Okay, you can solve. You can use any method. Okay, let's focus on this first. You can use any method. Later on, I will share with you the methods. Confused. Fortune, you have not even tried, you say confused already. Please think. Yes, you must try, of course. Don't know? Try. Okay, Ahmad Akmal. Yes, the answer is 33. Okay, those who will get the answer 33, what method do you all use? How you all do? Anybody use guess and check? Okay, some of you use set method, grouping method. Okay, 3-step guess and check. Okay, so let me show you. Now, some students, if you do not know the grouping method, okay, you would use the guess and check method. Okay. Now, this is an example of guess and check. So you can see there are twice as many $2 notes as $5 notes in a bag. So basically, you do not know. They tell you that there are twice, but you do not know exactly how many $2 notes and how many $5 notes. But they tell you the proportion. The proportion is 1:2. Okay. So $2 notes, 1 unit. $5 notes is $2 is 2 units. $5 notes is 1 unit. Right? What is the value? So the value is $2. So $2 multiplied by 2 units, you get 4. Okay, $5, you get 5. And then total is 9. So you continue using guess and check. You check and check and check until finally you get the answer. Okay, so what's the problem with this guess and check method? Anyone can tell me what's the problem with guess and check method? Very lengthy, very good, very lengthy, very tedious. Right? I've seen students spend 15 minutes on a 2-mark question using guess and check and cover the entire paper. And the worst part is that at the end of it, they still get the answer wrong. Okay, use guess and check. You write and write, guess and check, guess and check. In the end, also get the answer wrong. Okay, so there's a problem there. Right? But primary 3, primary 4, okay, maybe you can do guess and check method. But primary 5, primary 6, you cannot do anymore because the numbers are very big. Impossible, okay, that you use guess and check method. You can, if you got last resort, if you got no other method, I always tell my student, if they feel that they have to use guess and check, they got no clue at all, keep the question to the last, to the end. Lastly, let's say you have the last 10 minutes, that's the only question that you need to solve, and you got no other way, okay, go ahead, use guess and check. Other than that, please do not use guess and check. Okay, there are other methods, okay, that you need to know. Okay. Right. Now let's use the same question using number times value. So how do you solve this? So first you can draw a table, right? You can draw a table to present your answer. So they tell you that there are twice as many $2 notes as $5 notes. So I just write down $2. These are $2 note. This is $5 note. Sometimes there are 3 or even 4 variables. And how do I get 2 units and 1 unit? From the keyword here. Okay, there are twice as many, twice 2 units, and this is 1 unit. Now, next, I need to find the value. How I get the value? You just multiply, right? $2 multiplied by 2 units, $5 multiplied by 1 unit. Okay? So when you multiply, right, you get 4 units here and 5 units here, and you add up together, you get 9 units. Okay, so this represents the number multiplied by the value. Those of you using set method or the grouping method is actually very similar. The only difference is that you do not draw the table. Okay, you did not present the answer as in a table form. Now, how do I get this? 9 units is 297. How do I get 9 units as 297? From here, the clue given to me. They tell me that the total amount of money in the bank is 297. And you have 9 sets here, right? 9 sets. So then we need to find 1 unit. So 9 units is 297. Divide by 9, I get 33. Now, why is the answer just 33 here? Because the question asks, how many $5 notes are there? And $5 notes, how many pieces of $5 notes? From this information here. Okay, from this information. So this is 1 unit. There are 33. So you leave the answer as 1 unit. There are 33 $5 notes. Okay, so you can have a variation. They can ask you, what is the total value of the $5 notes? Then you cannot put 1 unit. You must multiply by 5 units. Okay. Okay, Vera asks, wait, how do you determine what to multiply by? I mean the first example. Okay, how do you know what times what? Very good question. You look at here. Here the value is $2, right? Here the value is $5. And the number of units, meaning that what is the proportion? Twice, right? Twice means 2 and 1. 2 units is to 1 unit. So what do? You multiply $2 and 2 units. Here you multiply $5 and 1 unit. Why? To get the total value. Remember, this is just for one. This $2 is for 1 piece. But we do not know how many pieces are there, but we know that it is 2 units. So 2 units multiplied by $2, you get 4 units. Here, 1 unit. For $5, 1 unit multiplied by 5, I get 5 units. Okay, so 4 units plus 5, that means I have 9 units. Or you can say 9 sets. Or 9 group. So those of you who did in grouping method or the set method, you understand that this means 9 units, 9 sets, or 9 groups. Okay? Then they tell you that the total amount of money is 297. So 9 units is 297. You find 1 unit, you get 33, and this is the answer. Okay? All right. Let's move on. We only have about 15 minutes. Okay, so if you don't understand, no problem. Later on, when I upload on the YouTube channel, you can always review the lesson again. Okay, last method. Are we ready? Supposition assumption method. Okay, let's move on. Okay, first of all, who have not heard of the assumption method before? Never hear before? Never hear before? Devin, please focus. You should focus on the slides rather than on the chat. Never hear before? Okay, no problem. Okay, what I'm going to show you is that I'm going to use a past PSLE question and to show how this strategy is being done. Is it okay? I'm going to show you using actual past PSLE question, and you will see how to do this method. Okay, we call this assumption method or the supposition method. Okay, so this is taken from 2013 paper 2, question 15. I think this is a 4-mark question. Okay, now I'll give you 3 minutes to solve this. Okay, I want you to take a piece of paper, your calculators, you need your calculators, and then I give you 3 minutes to solve this question. Okay, can you do now? No spamming, everybody must try. If not, I'll ban you. Devin? Please try now. It is not 40, it is not 15. Don't hantam only, yeah. Please don't be distracted, huh? Everybody must try. In 2 minutes time, and then I will tell the correct answer. Everybody must try, huh? One more minute. Try. Okay, the answer is 230. Okay, the answer is 230. Some of you got the answer, very good. Now, those of you who got the answer, what method do you all use? What method do you all use? Anybody use guess and check? Yeah, Sora, very clever. You're the first one to get the correct answer. Sora, how many marks you get last year for your maths? You got 90. Oh, well done. So, Sora, you need to aim for an A star for your PSLE. Is it okay, Sora? Ishak also, you must aim for an A star. Those of you who get 80 something and above consistently, you must aim to get an A star. Maths is the easiest subject to get an A star. Aim 100, even better. 100 full marks, even better. Okay, are we ready to discuss? Confusing, indeed. Yes, it's coming, but it's a past PSLE question. Now, this one, you should be able to solve. This is the P5 student, you should be able to solve also, right? Because this is not complicated. This is just a whole number. Okay, P5 student, even P4 student should be able to do this question. Okay, this one is a P4 question actually. All right. Okay, so now many students, okay, I'm going to show you using supposition method or the assumption method. But assuming that you do not know the assumption method, or if you do not know assumption or the supposition method, you will most likely use the guess and check method. Okay, the guess and check. Okay, why? Because it's a little bit confusing here because there are two variables. You can see Meng sold a total of 368 large and small durians. So the tricky part is that they do not tell you how many large and how many small. Okay, so here we are talking, number one is the number of durians. Secondly, we are talking about the prices of each durian. Okay, at one point, at one of the variables is we are talking about the number of the durian. Number means what? 1, 2, how many durians? 1, 2, 3. Secondly, we are talking about the price. They give you the price. Large durian costs $5, $9. The small durian costs $5. And they tell you that they collected a total of $2,760. So how they get 2,760 is the price of the durian multiplied by the number of the durian. The only thing is that we do not know how many large durian and how many small durians. Correct or not? Okay. Now, if you do not know how to use the assumption method, you will use the guess and check method. Let's see, let's see how to use the guess and check method. Okay, so you know that there's a total of 368. So then you make a guess. So let's say large 200, small 168, right? Total you get 368, and then you multiply, right? Large durian, since each large durian is $9, so 9 times 200, you get 1,800. Okay, small durian $5 multiplied by 168, you get 840. So when you add up together 1,800 plus 840, you get 2,640. Unfortunately, it is different. So you cannot use this number. And then you're going to try again and again and again. You try 210, also cannot. And then you try, so on, you try and try and try until you get 2,760. And you can see that this is going to be extremely time consuming, okay, and probably when you take 15 minutes, 20 minutes to do this, and by then PSLE over already. Okay, all right, so this method is very confusing and it's very long, very tedious. Okay, so I'm going to teach you a shortcut method using the assumption method. Okay, anybody can tell me what is the step number 1 to use the assumption method? Anybody can tell me what is step number 1? Assume what? First, you need to assume, right? You assume what? Assume all the same. Right? What do you mean by assume all the same? No, you assume what the same? Yeah, you assume all the durians is either large or all the durians are small. Okay, so I'm going to assume that all the durians are small. You can assume both. All the durians are small and all the durians are large. Both of these assumptions, in the end, you get the same answer. Okay, so I'm going to show you both. If I assume that all durians are small. Okay, let's see. Okay, so you're assuming all the durians are small. Okay, that means all the 368 durians are small. So 368 multiplied by $5, I get $1,840. But there's a problem here, right? Because you can see here, he collected 2,760. There's a shortage, correct or not? There is a deficit or there's a shortage. Now, why is there a shortage? Why the answer here is not 2,760? Why? Sora, why? Because, remember, not all durians are small. Yes, not all durians are small because some of the durians are big. Okay, so we are going to account for this shortage, okay, of the money. So step number 2, we need to find the difference, right? Difference between the actual amount collected and the total amount based on my assumption. So 2,760 minus the total collected, if I assume that all are small, so I get a shortage of 920. 920. Now, can you tell me what's the next step? Anyone can tell me what's the next step? Nine minus 5. Oh, Arik, well done. Arik, why 9 minus 5? Anyone can tell me, other than Sora and Arik, can you tell me why 9 minus 5? Because we want to find the difference of 1 unit. Okay, we want to find the difference of 1 unit, right? Because one durian, large durian costs $9, one small durian costs $5. So the difference is 9 minus 5, I get $4. Iman, you're very sharp. Huh? I'm not eating, I'm drinking. Okay, so minus $9 minus $5 equals to $4. Now, what is the next step? Now, can you tell me what's the next step? You find the you divide. Correct or not? You divide 920 divide by 4. Excellent, right? And then you get 230 and you get the answer, right? So because why? Now this 920 is due to the large durian, and since the difference is $4, when you divide, you get 230, right? So this is the total number of the large durian. Easy peasy? Easy, right? Rather than doing the guess and check method. Fuchun, yeah, initially it's not difficult, it's not easy initially, especially the first time that you learn this method, but you need to learn and try and remember and internalize the method. Okay? Okay, now let's assume that the durians are large. Okay, we can also assume all the durians are large. No problem. But we just need to add one more step. Okay, now step number 1. Okay, we'll go back. Step number 1, total collected. If I assume all the durians are large, so 368 multiplied by $9, I get 3312. So you can see that 3312, I've overshot already, right? Okay, I've overshot the actual amount collected, which is 2760. Then what you need to do? Very good, Arik. We minus 3312 minus 2760. You get 552. So this is the extra. Correct or not? This is the extra. Okay, so what I do again, the next step is I find the difference, right? $9 minus $5, I get $4. When I divide, I get 138. But this 138 is small durians. But they didn't ask for small durian, they asked for the large durian. Okay, so I just need to minus, there's one extra step that you need to do. 368 minus 138, you get 230 as the answer. Okay? Which is preferred? Okay, it's either way, you can assume all large or all small. If you assume all small, then you save one step. If you assume all large, you just need to do one extra step. So in the end, you get the same answer. Okay? So it's exactly 9 o'clock. Okay, I will leave some time for Q&A. Any of you have any questions regarding this 4 strategy? Some of you confused, yes. Obviously, some of you may be confused. Like I say, these are quite advanced technique, advanced strategy for your paper 2 question. If you don't understand, it's perfectly normal. Okay, what you need to do is that you need to review what I've taught you. Okay, and when I upload online, you need to review. You can pause and listen again and again. Okay, everybody, you have different level of understanding. Some of you take a shorter time, some of you take a longer time. Some of you have learned before in the past, then for you it's easy. Some of you have not learned, first time you learn, then obviously you will take a longer time. Okay, so anybody has any question? Okay, does the different step in assumption apply to all questions? Yes, you have to. How to make less careless? Okay, Sora asked a very good question. How to avoid, I assume you're asking how to avoid a careless mistake, right? Now, careless mistake is very common. All humans, we tend to make careless mistake. Everybody make careless mistake. The thing is that we need to minimize, okay? If you are, you need to minimize the careless mistake. Okay, one way is for you to check your final answer. Obviously, it's not that easy because that is assuming that you have time. Okay, but sometimes or many times you are shortage of time, you don't even have time to check. Okay, so the easiest is for you to check each time that you do a question. After you do a question, immediately do a quick check. Okay, one of it is you can check your units, whether you put the units or not. Secondly, you check for transfer error, whether you make any transfer error or not. Okay, then you can also check whether your final answer makes sense or not. So instead of checking right at the end, you can check at every single question. Okay, spend some time. If you are, after some time, you get used to it. Okay? Working backwards, yes. You can work backwards also, right? You work backwards or use alternative method. That's why I need to teach you different methods, right? We use one method and then when you check, you use another method. Then you can see whether your answer makes sense or not, right? If you use assumption method, what you can do is that when you work, when you want to check, right, then you substitute back the final answer to the question and you can see whether the answers make sense or not. Okay? Can you go back to the slide back? Okay, which slide? This one? Isak, listen, Isak, I noticed that you tend to make careless mistake. So you get 96. I think the 4 marks you lose is because of careless mistake. Correct or not? Okay, so you need to be a little bit more careful in your marks. It's very common that you make careless mistake, but try to minimize. Okay, it's not easy, but with practice you will tend to minimize the careless mistake. Okay, like PSLE maths is not easy. Okay, it's not easy. It's very, questions are very tricky. Sometimes we think that it's easy, right? Many students say, teacher, wow, very easy after the exam. Then in the end they don't get the marks, right? Because PSLE question is very tricky. Not difficult, but tricky. Okay.